Well, g'day, Max here again. Welcome back to the shop. So this episode we're just going to take a slight detour from our grinding fixture. And what we got here on the bench is some clutch components out of a lawnmower. Now the make of the mower, I think it's an Australian one. It's a classic, I'm sure it's a classic Australian one. I think it's an Alroh. I'm sure they're not English, I'm pretty sure they're Australian. Anyway, we've got some clutch components here that are flogged out to get back into a serviceable condition for this lawnmower as it's getting a complete overhaul. It's not mine, it belongs to someone else. So we'll swing in and we'll show you what we've got to achieve. So as an assembly, it's like this. So what we have is it's actually it's a cone clutch. So you have the cone there and the outside cone here, friction material on it. And spring pressure pushes the inner cone against the outside cone. The outside cone is attached to the inside cone, which is on the motor. So everything's all a bit flogged out. That's still good. So this cone goes on the shaft, and because it works in a sliding fashion like that, I think it has a fork on the back, pushes to release the cone clutch. So that's a bit flogged out on there, so there's a bit of wear on the shaft and there's a lot of wear inside the bore here. So we'll probably look at just skimming that bore to a clean up, to true the bore up, and with the shaft where it's warm we'll do an oversized section on the shaft, so that'll take care of that. Now we'll either make a new shaft or we'll repair this one, so that's yet to be determined. So it's those parts, there's nothing, and the hub, this is it's either aluminium or die cast, I don't know. It's all wallowed out inside the bore where it fits onto the motor. So once again, one option is to make a complete new one out of steel, or what we could do is repair this one. So that would have to be bored and sleeved. But there's issues there, which isn't nothing that can't be overcome. So you have this, the light's going to blow it out, you might see it there. Okay, there's a big cutout section here. I'll bring you in a bit closer. Okay, so on the hub there's a big cutout section here which does nothing. I don't know why it's there, no idea. So the bore's wallowed out, so is the keyway. The problem with this is this cutout section, these three grooves here, and those three grooves are also on the inside behind the bearing. We'll have to pull this bearing out. So this is actually, if this is weldable, it's repairable. So what I don't know, is this proper aluminium or some crap die cast? Being Australian and quite old, I'm hoping it's aluminium. What we'll do is I'll just clean up a section. We'll just do a test weld on it. If the weld looks shitty and doesn't take, it's possible it's die cast. Who knows what this thing's made out of. If that's the case, then we have no option, we'll make up a steel one. So this is actually for my son-in-law, so just doing a little job for him. So let's get this bearing out first and we'll clean up a spot here and we'll just see if it's weldable. So just before we play with that hub, I found this long bolt. It's a 10.9 grade bolt. So it's a very high strength bolt, high tensile bolt. So I think we'll use this to make the shaft out of. I won't bother about building this up. I'll just make a new shaft. So we'll just cut the head off, cut the thread off, chuck it up in the lathe, and it's just a straightforward turning operation. So we'll get the shaft out of the bolt. Before we do the shaft, we will put this in the lathe and sort this bore out. Then we know the size that we have to do this oversized section, which will be just in this area here. Okay, so this is the first part we're going to tackle. We'll straighten this bore out inside. So this part here has some challenges to hold on to in the lathe, if we do it in the lathe. So we've got as you can see, both sides are tapered. We do have a machined face on the side, on the end of it here, and the inside is just cast. So you could put this in a 3-jaw chuck using the reverse jaws, or if your chuck was big enough, the other set of jaws, the external jaws, so you'd be clamping up against the face, but you're still contacting on this knife edge corner. So if you did it in a 3-jaw and you had any run out, it's pretty difficult to deal with. It can be done, you've got to shim it, but it's a pain in the ass. You could do it in a 4-jaw, same thing again. No, you're just gripping on this very knife edge corner here. So it's quite a delicate part as it's cast iron, and so if you over tighten that, it should fracture. There's another option. Mag chuck. We can pop it down on there. Turn the chuck on, and that's going nowhere. So I think I'll get this chuck clamped down on the mill table and we'll do it that way. So we'll head over to the surface plate, we'll put some wet and dry down and just tizzy up this mounting face here, make sure there's no irregularities there. Okay, so we've got a bit of 400 wet and dry. We don't very often use the surface plate, it gets more use as a shelf. So in the new shop, of course, we'll have room to keep it set up properly. But okay. It's coming up alright, just a tad more. And that'll do it. So we'll see how that feels when it's on the mag chuck. Yeah, so you guys never really get to see my surface plate. Needs a good clean up, but it's an old cast iron one. Doesn't have a maker, so I don't know what brand it is, but at a guess I would say it's quite possible it was made in the railway workshops. Because I know when I used to work in railway workshops, things like this used to get made, but as for its flatness, it would be interesting to have it actually checked one day and see how it goes, but no, for what I do, this is plenty good enough for me. I don't need no AAA grade one that I'd just damage anyway, so this will do the job. So we'll get this set up when we're in the new shop. This will be set up properly. Yeah. Anyway, back to our part. So just colour strap clamps to hold it down, and these just only need a very light net. That's all they need. As we don't want to distort the underside of the mag chuck where we're clamping over the T-slot there, so that will be fine. So we'll get our boring head set up and get this indicated in. Okay, so we'll just use our tool initially just to centralise the part. Okay, that's close enough. We can indicate off this face now. So somehow we'll get this indicator lined up. Probably something got clearance. Not quite clearing there, we'll just come down a bit on the table. That's all we need. Okay, so we're on 60 there. Come round on 25, so we'll just split that in half. Come back to 40. Couple of thou more. 42, 42. Split this way, 42. 42, 43, so we want 42 and a half this way, 42 and a half, 42 and a half, move to 42 and a half that way then. 43, 43, yep, so I'll lock table off, we'll see what's changed. I'll just come back to a whole number, 50, 50, 50.5, oh sorry, 49.5 and 49.5. So that's running within slightly out of round, it's about half a thou out of round. Oh, actually it's a thou out all up, so you've got half a thou difference between there and there. So there we're minus half, plus half, minus half, come back around this side, plus half. So that's central, and we're locked. Okay. Crank the mill up. We'll take a trial cut through. I'll make sure my quill's locked, because I'm coming up and down on the... No, actually I'm going to come up and down on the quill. Just had to pop the quill wheel back on. As our last job, as you would have seen, we had the indexing head quite tight up in that area, so with the indexing head on I generally take the quill wheel off. I don't bother with the original Bridgeport handle. I've got it somewhere, but it's shagged, it's rooted. So anyway, let's get this touched off on the side and put a cut through. Okay, we just want to wind the tool in just so it's just contacting. I think we're pretty close there. Okay, we'll run that through, see how we're looking. After we put the machine in gear, would help. Take a fraction more. Try that. This actually cleaned up quite a bit of that. So let's see if I can get a size. I'd like to bring it to a standard size. Say 10, it's 3/4 of an inch. But yeah. I'd like to still bring it to a standard size, say 760 or something. That's 756.5 there. So I think I'll take another 5 thou. I'll get our indicator set up on here so we can take our cuts. So I'll just do a 3 thou, very light 3 thou cut on that. That should take it to 760. Might have to go 15 or 20 thou oversize yet to bring it to full cleanup, but we'll see how it goes. Made in Sheffield, with a little bit of English gear. Everything's magnetised. We seem to have got a full clean-up there. Yeah. See how we're travelling for size. Trouble with things get with this magnetic swarf because of the chuck there. You gotta be careful it doesn't get stuck on your measuring gear when you're taking a size. Okay, we're 762 and a half. So what we'll do is we'll go for a standard of size of 15 thou over. So if we take another 2.5 thou out of that, that'll put us right on 765. So 2.5 thou, that's 1.25 thou. So I'm just going to play it safe. I'm just going to take 1 thou. Okay, let's run our bar back through. That's come out great. Bloody camera in the way. Put our size smack on. Feels good. So, with 15th thou oversize on its original 3/4 inch bore. Yeah. Okay, we can make our shaft to suit that now. So good result.